All right, here we go. Homework page 2.2 from last night. Have that out to correct. Answers are coming up right now.
Which one is that? The leopard one? Maybe you left it right here the other day.
I did see it there a couple days ago.
Where'd you move it to?
There's quite a bit on this page. Oh, let me open up my chat. So if you have questions, you can pop them into the chat or just unmute yourself and shout them out. If you notice on these first two, I circled the word and because and means decimal. So that kind of helped me see where I had to put my decimal point. The last three didn't have the word and, but the fact that it had the THS was my hint that I needed a decimal in there.
On number 20, I think it's supposed to be 5 and 106.
You're right. Thank you.
Oh, I found it.
And then for 26 and 27, remember we talked about how you can just add zeros at the end of them all day long to make equivalent decimals. And then you needed to take these three decimals and write them as fractions. And right here was kind of my explaining to somebody how that worked. Because if we had, looking at this one, I had like 2 and 6/10 and 2 and 60/100ths. Well, 6/10 is like 6/10, right? And 60/100ths is 60/100. Those are equivalent because I can do 6 times 10 is 60, 10 times 10 is 100. I'm multiplying the top and the bottom by the same number. So that's what makes them equivalent. All right, ready for the backside?
No.
I will be adding these to Otis, so you'll be able, if you didn't get a chance to get them all, you'll be able to find them in Otis to finish correcting. Number 11 was a little different. I didn't realize when I was talking to you guys about it that it said number lines. So they didn't want the bars, the fraction bars like we did yesterday. They wanted number lines to show that they're equivalent. Oh, I forgot to do one. For 5 and 6, my estimating I did over here to the side so you can kind of see what I rounded them to before I added or subtracted. So again, this right here was my estimating. Remember we talked about those benchmark fractions. You round to 0, 1/2, or 1.
And I'm supposed for that.
Gabby, do you have any questions?
Oh, wait. No, I don't. I accidentally unmuted myself.
Anybody else have questions? Don't see any in the chat. I don't see any hands up in the participants. If you're virtually raising your hand, I can't see you, so just unmute yourself and shout it out.
This triplet.
Yes.
Can you move your paper down so I can see the bottom?
Okay, yeah, it's all there. This is the bottom.
Wait, now I see it. I'm done.
When you're drawing your number lines or your fraction bars, you want to try and draw them so they're about the same length as each other also, because that helps you really show that equivalency. All right, let's go ahead and switch over to lesson 2-3. 2-3, we are, and this is on page 43. We skipped a bunch of pages with those like secret code cards or whatever they're called. And we're gonna hop over to this, visualizing with other models, page 43. All right, so it says the bar below represents one whole. So from here, this would be 0, and this would be one whole. So these darker lines are tenths, right? 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. There are 10 tenths in a whole. How many of these little teeny lines do you think there are in this whole?
100.
There's 100. Yes, those are our hundredths. Each tenth, there's 10 in each tenth. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There's 100 hundredths in our whole. So first it says shade 6/10. So if I'm shading in 6/10, that's 1, 2, 3, 4, 5, 6. I want to shade in all 6/10. How many hundredths is that?
60 hundredths.
60 hundredths, yes. 6/10 is the same as 60 hundredths. 6/10 and then 2 hundredths. And then I'm going to shade in just 2 little itty bitty ones. 6/10 and 2 hundredths. Okay, so the drawing shows us 2 different things. It shows us 6/10 plus 2 hundredths. I had my 1, 2, 3, 4, 5, my 6/10, and then 2 hundredths, 6/10 and 2 hundredths. But also, like we just said, it shows us 60 hundredths because each one of these tenths has 10 hundredths in it. So 10, 20, 30, 40, 50, 60 plus 2 more hundredths to give us 62 hundredths. So those are equivalent to each other, right? 6/10 plus 2 hundredths is equivalent to 60/10 plus 2 hundredths. Remember, we talked about this yesterday. We can add these zeros at the very end all day long and it won't change the value. Okay, it still makes it the same. All right, here we have a number line that's labeled from 0 to 1 whole. What is it broken down into? Is it broken into tenths or into hundredths?
10 hundredths. 10. 10.
Tenths. It's broken down into tenths. 1/10, 2/10, 3/10, 4/10, 5, 6, and so on. It's broken into tenths. If we need to begin at 0 and circle a distance to show 28 hundredths, we're going to go 2/10 plus 8 hundredths. So we're going to go all the way to our 2/10 and then almost to 3, but not quite, right? Almost to 3, but not quite. Because 8 hundredths almost gets us to that 3/10 mark. But it just is a little bit short. It's 2 hundredths away from it. Okay. You try the next one. Circle a new distance to show 74 hundredths. You circle 74 hundredths. See how that looks on yours. Let's see. I'm going to go to 7/10. And then 4 hundredths is less than half because 5 hundredths would be half. So I'm going to go about to there. So I'm going to go all the way back to 0 and all the way back up to there. Is your circle close to my circle?
Yeah.
Hopefully, yeah. 7/10 and 4 hundredths. Again, a little less than halfway because halfway would be 5 hundredths. Are we okay on our bar and our number line?
Yeah.
Yeah.
Okay. Now we're gonna look at these grids and we're gonna do some more shading. I should have told you guys it was a coloring day. Some more shading. Let's look at these first. How many units are in one of these squares?
100.
100, yes. So how many do you think are in each one of these rows if there's 100 in the whole thing?
10.
There's 10 in each row. So if I'm going to shade 4 tenths, which is the same as 40 hundredths, do I need to count out 40 little squares?
No.
No.
No, what can I do?
You can just
Count.
count the very
4 rows of 10.
Yep, I can just color in 4 rows because I know that each row has 10 squares in it. So if I color in 4 rows, that's going to be the same as 4 tenths and 40 hundredths because there's 40 little squares that I've shaded in. You guys try and do B. What would 36 hundredths look like? 36 hundredths is 3 tenths plus 6 hundredths. Let's see, if I was doing it, I'm going to have my 3 rows for my 3 tenths or my 30 hundredths. And then I have to color in 6 little ones. 1, 2, 3, 4, 5, 6. Did you guys come up with the same thing?
Yep.
Yes.
Yeah.
Yes.
Yes. Awesome. Next one gets a little tricky. Because next one is asking us to shade in 1,000. Can someone raise their hand and tell me what they would shade to show 1,000?
They would probably shade
No, I
one.
asked for a raised hand. Give me a raised hand. Make sure we give. We're not talking over each other on this one. Morgan, I see your hand is up.
Maybe you like divide.
Hang on just a second. If you're not Morgan, please mute right now. If you're not Morgan, please mute. There we go.
Maybe you can divide one of the squares.
What am I going to divide one of the squares into?
10 pieces.
10 pieces, yep. Because each one of these little squares is 100th, and 1,000th is 10 times smaller than 100th, 10 times smaller. So I want to take my 100th and think about what 1/10 of my 100th would be. So I'm just going to shade in just almost like the thickness of my pen or my pencil. It's going to show me 1,000th. I mean, my shading is probably even a little big. But 1,000th would just be one teeny tiny part of that. Something that sometimes you'll see is they'll like have one circled and then an arrow come over and they'll draw it bigger. So this is saying like, oh, we took that little piece and we made it, I think that's right. We took that little one and then that's what it would look like if it was divided into its thousandths. And then we colored in one of those for my 1,000th. Okay. Next one, use a sketch of money, a bar representing one whole, a number line, or one or more grids. We don't need to do that. We've been doing that. So one thing to notice, though, is that all of these decimals are equivalent to each other, right? 4/10 is the same as 40 hundredths. Can you guys see how 4/10 is the same as 40 hundredths? I hope so. All we did was add that 0 to the end of it. 36 hundredths is the same as 3/10 plus 6 hundredths, my 3/10, and then I go to my 6 hundredths, okay? These are all equivalent to each other. It's ways that we can break down these decimals. All right, let's take a look at the back side. We are going to skip the top part and move down to number 6. Number 6 is comparing our greater than, less than, equal. Here is my advice, my hint, my clue, my I really want you to do this when you're comparing decimals. I want you to stack one on top of the other one. It doesn't matter which one you stack on top of the other one, but when you're stacking them, you are lining up the decimals. Your decimals need to be in a row with each other. So what I'm saying, how I want this to look when you do it, is I would want you to take my 7/10 and put it right on top of my 7/100. I lined up my decimals, and then I've got my zeros lined up and my sevens lined up. When you compare, you're going to start to the left and work your way to the right. So I have a 0 and a 0. Is one of those bigger than the other? No, those are the same, right? I go to my next place value position and I have 7s. Those are equal to each other, right? And then I have a 0 and another 0. And I can even take and make these the same length if I want to, just to help me with my comparing. These two are equal. They're equal to each other because all they did was add zeros to the end, and zeros do not change the value. Okay, let's take a look at the next one. We're going to line them up. I'm going to put my decimal, 0, 0, 7, 0. Again, I want them to be the same length, so I'm going to throw a 0 down there on the bottom too. Now look at it. My zeros are the same, zeros are the same, sevens are the same, zeros are the same. Those are equal. Let's try the next two. Put my decimal in there. I have a 0. I have a 0 in the 10ths place and a 7 in the 100ths place. I'm going to throw my 0 on the end so they're equal. Are those two equal?
No.
No.
No, because I go 0, and then I have a 7 in one of my decimals and a 0 in the other. Well, 7 is bigger than 0, right? They're no longer the same. The 7 is bigger, so that decimal is bigger. Okay, let's do one more together. Let's get them stacked. 0, decimal, 0, 0, 7. I'm going to add my zeros on the bottom to make them so they're the same length. I'm going to start comparing. I have zeros. Oh, again, I have a 7 on the bottom and a 0 on the top. The 7 on the bottom is the larger decimal. As soon as I get to the first digit that makes a difference, I know, I can tell which one is bigger and which one is smaller. Okay, I'm going to give you guys 1 or 2 minutes to finish out through 21. Go ahead and finish through 21. I'm going to be working on them also, but you don't have to have your eyes on my screen if you know what you're doing. I'm just going to solve them and you can double check with my work. When you're finished, check my work and see how I did. How we doing, guys?
Good.
I did it exactly like yours.
Jackson, I see your hand is up.
Oh, I forgot to lower it from earlier.
Okay. Amaya, I see your hand is up.
I got one of them wrong.
Okay, what number?
Number 8.
Number 8. So if we're stacking them, I have 7 hundredths and 7 tenths. And I'm going to put a 0 on the end just to even them up, right? Because adding that 0 to the end doesn't change my value. And I can start with the 0. Zeros are the same. Move over one place. I have a 7 on the bottom and a 0 on the top. That means that this is going to be my larger number. So think about this like money. This is 70 cents. That's only 7 cents. Would you rather have 70 cents or 7 cents?
70.
70
I
cents.
might be able to possibly buy something for 70 cents. If I have 7 cents, I'm pretty much out of luck. Another one that I could see people getting confused on would be like number 12. Because you look at this and think, oh, that's 475 compared to 62. But no, it's not 62,
Yeah,
right?
but,
Let's add that 0 to even them up.
Yeah.
Okay, it's like 620, and we think about it like money, we would have 47 cents and 62 cents. So just because one of the decimals has more digits does not make it the larger decimal. Okay, add those zeros to make them so they have the same number of digits. That will really help you when you're comparing them. Are there other questions on any of these?
I don't really
All right, let's take a look at your homework. Let's take a look at homework. So the top part, you're just writing each amount as a decimal. So this is what we've been doing the past couple days. So it would be like 9 tenths. You're writing it as a decimal, okay? The next section, circle the value that is not equivalent to the others. Don't get fooled by the ones that are written as fractions. I would even take that fraction and write it as a decimal just so I can easily compare. So I have 5 tenths, 50 hundredths, 5 tenths, 5 hundredths. This is my one that is not equivalent to the rest. Okay, compare, greater than, less than, or equal. A couple word problems. You're going to be comparing the different fabrics down here in those word problems. And on the back side, just some more review. So for your math, you're doing page 3132. You guys have about 20 minutes until recess. So if you finish your math before recess time, I want you to hop on Math iReady. Okay? If you finish your math homework before recess time, I want you to hop on Math iReady. Let's take out our planners and get those filled in.